In this video, I will explain a simple Python program that simulates a basic water distribution system. This program lets us create nodes and pipes, then calculate how water flows through them based on pressure and resistance. Understanding how pressure, flow, and resistance work helps us appreciate how these systems function. By creating a simple simulation, we can visualize how water moves from one point to another and how pipes affect the flow. This topic also connects basic programming with real-world engineering concepts, making it both educational and practical. The program uses two dictionaries to store information. One dictionary keeps track of the nodes, which represent points in the system and hold a pressure value. The second dictionary stores the pipes, which connect pairs of nodes and have a resistance value. This section allows you to create the points of your system. You provide a unique ID and a pressure value in kilopascals. Pressure acts as a potential energy. In this simulation, water will always try to move from a node with high pressure to a node with lower pressure. This function creates the connections between nodes. It requires a resistance value, which represents physical constraints like pipe friction or diameter. The code stores the pipe-wise from A to B and B to A to ensure that water can flow in either direction depending on which node has higher pressure. It subtracts the pressure of the second node from the first and divides it by the resistance. If the result is positive, water flows from the first node to the second. If negative, it flows backward. This is a diagnostic tool that prints a summary of your entire network. It lists every node with its current pressure and every pipe with its resistance. To keep the list clean, it only shows one direction for each pipe connection, preventing the mirror entries from cluttering your screen. This section allows you to update the pressure of an existing node without deleting it. This is useful for simulating dynamic changes, such as turning on a pump or experiencing a drop in supply pressure, which immediately affects the flow rates in all connected pipes. This section allows you to update the pressure of an existing node without deleting it. This is useful for simulating dynamic changes, such as turning on a pump or experiencing a drop in supply pressure, which immediately affects the flow rates in all connected pipes. This function removes a connection from the system. It is designed to be robust by deleting both directions of the pipe entry in the dictionary. This simulates a valve being closed or a pipe being physically removed from the infrastructure. This provides a master view of the entire system's hydraulics. It iterates through every pipe and calculates the current flow rate based on the latest pressure values. It uses a set to keep track of calculated pipes, ensuring each connection is only reported once for clarity. The program runs in a loop, allowing us to continue adding nodes, creating pipes, checking flow, or reviewing the system until we decide to exit. Overall, this topic was chosen because it combines basic programming, engineering concepts, and real-life applications. It helps us better understand how water systems work and how simple code can simulate something used in everyday life.